You know, there's this incredible piece of technology that's quietly powering the entire AI revolution. I'm talking about the engine behind smarter search, those recommendations that just get you, and even the most advanced chatbots you use. So let's pull back the curtain and explore what this hidden brain is and how it actually works.
Oh, we've all been there, right? You type something into a search bar. You know exactly what you're looking for. But the results, well, they're just completely literal. They match the words you typed, but they totally miss what you meant. It's that classic frustration of a computer just not understanding a human.
Yeah, think about it. You're not just looking for words on a page. You're looking for an experience, a vibe, like a seaside resort or an oceanfront getaway. But the old search tools, they're just stuck on keywords. They're built for exact matches, which, let's be honest, is not how our brains or modern AI, for that matter, really work.
And this gets us right to the heart of the problem. The tools we've been using for decades to organize information are just not cut out for the new demands of artificial intelligence. We desperately need a way to search for meaning, to get beyond simple keywords.
Think of it like this. Traditional databases are like a perfectly organized phone book. They are amazing at finding exact matches. Look up a name, get a number. Super precise. But AI, it's facing a totally different challenge. It needs to understand concepts and similarity. It has to wade through all this messy, unstructured stuff like text and images. It's less like a phone book lookup and way more like asking a friend for a recommendation, where all the context and unspoken meaning is what really matters.
So how in the world do you get a machine to understand meaning? How do you teach it that seaside resort is basically the same thing as hotel close to the beach? Well, the answer is this amazing breakthrough that, believe it or not, involves turning concepts into a language computers get perfectly, math.
And that breakthrough is called a vector embedding. It's a wild idea. The core concept is you take something really complex, like a sentence or a picture, and you distill its essential meaning down into a list of numbers. It's like creating a unique numerical fingerprint for that idea. And the process itself is actually pretty straightforward when you break it down. You feed a piece of data, say a sentence, into an AI model. That model chews on it, analyzing not just the words, but the relationships, the context, the feeling behind them. And what it spits out on the other side is that vector, that long list of numbers that represents what the sentence actually means. Okay, but what happens when you have millions or even billions of these meaning fingerprints? Where do you put them all? Well, you can't just throw them in a regular old database. You need a system built from the ground up for this brand new type of data. And that system, that's the solution we've been talking about.
This is where the hero of our story comes in, the vector database. It's a special kind of system that is purpose-built for one job and one job only: to store, manage, and search through gigantic collections of these vector embeddings at lightning speed. Now, what makes these so special is that they're all about something called similarity search. They couldn't care less about exact matches. Instead, they find what's called approximate nearest neighbors. Basically, they find the items whose meaning fingerprints are the most similar to what you're asking for by calculating the mathematical distance between them.
Okay, so calculating the distance. What does that even mean? How does a database find things that are close in meaning? The concept is actually super intuitive when you think about it visually. It really is all about how close things are to each other. Just picture a giant, multi-dimensional map of ideas. Seriously. On this map, things that are related are neighbors. So king and queen, they'd be clustered right next to each other. Dog and puppy, same deal. But the vector for, say, cabbage? Yeah, that would be in a totally different country on the map, far, far away.
And it all boils down to this one simple, beautiful rule. The lower the distance between two vectors, the closer they are on that conceptual map. And the closer they are on the map, the more similar they are in meaning. That's it. That's the magic trick.
Now look, this is not just some cool abstract idea for a computer science class. I promise you, this is the engine running behind the scenes of tons of apps you use every single day. Let's take a look at where this tech is already changing everything.
So first up, semantic search. And this brings us right back to where we started. With a vector database, when you search for hotel close to the beach, the system doesn't just look for those words. It looks for vectors that are close to your query's vector. And guess what's close? Seaside resort and oceanfront inn. Finally, you get the results you actually wanted.
This is also the secret sauce behind those recommendations that are almost creepily good. When a service suggests a new song or a product, it's not just matching genre tags. It's finding items whose conceptual vectors are super close to the vectors of stuff you've already said you liked. It's conceptual similarity.
And this one, oh man, this one is a huge deal. Vector databases are absolutely critical for making large language models like GPT way smarter and more reliable. There's this technique called RAG, and it's basically like giving the chatbot an open book test. Before it answers your question, it does a super fast similarity search in a vector database to find the most relevant, up-to-date facts. The result? Much more accurate, trustworthy answers.
And this isn't just theory. This is happening right now. These are real products and projects being used by companies all over the world. Names you might hear are Pinecone, Weaviate, Milvus. These are becoming the absolute foundation of the modern AI stack. So if you remember one thing from all of this, let it be this right here. Vector databases are a fundamental shift. We've literally moved from a world of rigid, exact keyword matching to a brand new world of fluid, contextual understanding. Machines can finally search by meaning.
This technology really lets AI bridge that massive gap between what a human intends and what digital data actually says. It gives AI a new kind of brain, one that can finally, truly understand us. And that leaves us with one massive question. What are we going to ask it to find next?